This is Dr. K. Raghuram Mohan Reddy, Professor of Mechanical Engineering Department. The course name is Unconventional Machining Process. So today's topic is that parameters affecting the quality of holes through drilling in conventional, in unconventional machining process. Right. At the end of this session, student will be able to understand parameters affecting the quality of holes. Of course, here let us start the just parameters affecting the holes and subsequently the various applications of this unconventional machining, particularly drilling of holes. Okay, right. So before this, let us see the non-traditional machining process through this laser beam machining. Okay, right. So under this, there are three categories: mechanical, thermal, chemical, and electrochemical. First one is ultrasonic machining under mechanical, water jet machining, abrasive water jet machining, ice jet machining. So in chemical and electrochemical, chemical milling, plasma chemical milling, electrochemical. Under thermal, electro discharge machining, electron beam machining, laser beam machining, ion beam machining, plasma beam machining. Now, today we are discussing laser beam machining and applications of laser beam machining, and particularly the process parameters affecting the quality of holes by drilling. Right. Now, let us see the laser drilling capabilities. Okay. So, these are the hole features, and this is the range for the laser drilling. Okay, so diameter 0.005 to 1.27 millimeters, larger in trepanning. Depth 1.7 mm, angle 15 to 90 degrees, taper 5 to 20% for diameter, depth to diameter ratio 50:1, drilling depth for trepan it is 6.4 mm. Tolerances plus or minus 5 to 20% diameter, minimum corner radius 0.25 mm. So these are the parameters involved in laser drilling. Now let us see the physics behind the quality of holes for the laser drill holes. Okay, right. Quality of holes of laser beam machining involved five major categories. Okay, the first one is working material, second one environment, third one laser pulse and assist gas, focusing lens. Again, in each category there are subcategories. So in working material, the type of working material and its surface reflectivity and thickness of the workpiece material. Again, in environment, the major parameters are humidity and temperature. These two influence the quality of the hole by laser beam machining. Next, laser pulse. Pulse shape, frequency, wavelength, beam, divergence, duration, energy, transverse modes. Okay, so these laser pulse parameters influence the quality of holes most predominantly. Okay, right. Next, focusing lens. In this, again, there are two important parameters: focal length and focal position. Okay, assist gas for the laser beam machining setup. This type of gas and pressure. Third one is nozzle design. These three influence the laser beam machining through laser beam machining, drilling hole through laser beam machining. So for which the quality of holes will be the output, influencing these five major classes. Right. So quality of hole is an important application for the different organizations like medical devices or surgical units, and sometimes aeronautical parts and products, and aerospace, shipbuilding, and there are so many applications of this laser beam machining with holes. Okay, hole making is very important, particularly for the medical field, right? So in this, importantly, the pulse energy is a important parameter. It is recommended that the required peak power should be obtained by increasing the pulse energy while keeping the pulse duration constant. So here pulse duration should be keep constant, and we have to increase the pulse energy. Okay. Next, drilling holes with longer pulses causes enlargement of the hole entrance. Okay, so longer pulses cause enlargement of hole. Okay, at the entrance. Next, pulse duration. The range of pulse durations suitable for hole drilling is found to be from zero point 0.1 to 2.5 milliseconds. So here the time duration is very less, zero point 0.1 to 2.5 milliseconds. Okay, make a note that here the units are in milliseconds. Right. Next one, high pulse energy, that is 20 joules. Okay, and short pulse duration are found suitable for deep hole drilling in aerospace materials. Just we have discussed that this laser beam machining hole making is very important in medical and aerospace engineering. Okay, so drilling a hole is an important feature for all flowing and the other functional elements of the medical field and aeronautical field. So we must take an ultimate care towards the quality of the making hole in these fields, so that we have to use laser beam machining particularly in order to get the high efficiency and high accuracy. Okay, right. Now let us see the applications involved in different areas for the major and minor industries or fields. Okay, so the first one is drilling. Okay, so now we are focusing on this drilling very particularly. See, the other applications are plating, heat treatment, cladding, alloying, welding, and machining. Okay, now today let us confine to this drilling application. Okay, right. What is drilling? Composite materials and some exotic alloys have been widely used in the fabrication of both structural and non-structural members of the airframes and engines of aircrafts. Okay. Next, superalloys are used frequently for the fabrication of aero engine gas path components such as blades, guide vanes, afterburners, and castings where a temperature of 2000 degrees centigrade can be reached. So here the important one is the temperature is about 2000 degrees centigrade. Okay. Advanced ceramics and titanium alloys are being developed and used. Such materials need advanced technologies in their fabrication and processing. See here, titanium alloy is very hard material that we cannot machine through conventional machining process. It is very difficult to turning, even milling through our conventional lathe machines or milling machines. So we have to go with some unconventional machining process. So very particularly, we have to use laser beam machining for machining of titanium alloys. Right. Even for drilling titanium and other hard materials, laser beam machining is the very best choice. Right. Conventional drilling and punching are found to be insufficient because of the material toughness and high strength. Okay. So here titanium alloy is very tough and hard material. Okay. Of course, some poor characteristics are also there. Titanium. So though it has poor wear characteristic, but it is very tough and hard. Okay. So that we have to go with laser beam machine. Right. So other conventional process such as electrochemical machining, electrochemical drilling, EDM, that is electro discharge machining, ultrasonic machining USM, water jet machining, and abrasive water jet machining. Okay. Okay. So these suffer from the high cost of tools and long lead times. Okay. So that we have to go with laser beam machining so that it will be feasible for making holes through drilling. Right. The capacity of laser beam machining to produce fine holes at high machining speeds compared to other machining process is reviewed by Snowy et al. During 1986. So this Snowy is researched that laser beam machining is good in the aspects like machining speed and other cost effectiveness. Okay, so since the 1970s, laser drilling has proven to be an efficient drilling tool in terms of cost, quality, and reliability of large scale production applications. Okay, so initially we have to establish the laser beam machining, maybe a difficult one in terms of expenditure and the utility, but for the large scale production applications, definitely it is very good in terms of cost effectiveness, and in terms of quality and reliability is also very good. Right. Laser drilling is performed by the following three methods. Okay. So about operations and the manufacturing methods, the drilling is extended like direct drilling, drill and rim, tree panning. Okay. So simply making a hole is a drilling, but what drilling and drill and rim, tree panning will be. Okay. Right. Produce the required hole size by application of one or more focused laser pulses. The hole size is determined by the input power and the focusing adjustments. While most holes are drilled with single laser pulse of high energy, it is more efficient to drill deep holes with multiple pulses of low energy. So instead of using high pulse energy with single laser, we better go with multiple pulses of low energy. Okay, so this is just like our exercise. Okay, instead of lifting more weight for short interval of time, okay, so better we lift and down the less weights, okay, constantly for about more time, then it will give good impact on the um, requirements. Okay, so similarly here multiple pulses of low energy is the better choice for the deep hole drilling. Okay, right. Next, so here drill and ream consists of drilling a pilot hole and then changing the laser parameters by increasing the spot size to open out the hole to the required diameter. So here this is just like our conventional method of reaming only. So first we have to make a normal or conventional drill hole. So later on we have to enlarge it to our requirement. So that is nothing but reaming. Okay, right. Trepanning. What trepanning is? Use it for large holes by either moving the part or rotating the laser beam system of delivery or lens. So because of the low energy of each pulse, the recast layer and out of cylindricity are reduced. Okay, so here what is happening? Low energy of each pulse, the recast layer and out of cylindricity are reduced. Okay, the process, however, provides easier control of the hole size by rotating the diameter of the beam. Okay, so here what we are doing, we are rotating the diameter of the beam. Okay, so we are not rotating the workpiece. So here we are rotating the diameter of the beam in order to make a hole that is nothing but the trepanning. Okay, next, hole quality characteristics. So this is our main objective of today's topic: diameter and depth, taper and barreling, recast layer and micro cracking, entrance angle, drilling depth. So these are the parameters which influence the hole quality. Okay, right. Diameter and depth. Using laser beam machining, it is economically effective to drill holes up to 1.5 mm in diameter. For large diameters, the trepanning method is recommended. Okay, so just we have seen that for trepanning means for larger diameter holes, usually we rotate the laser beam instead of rotating the workpiece. So that is nothing but trepanning. Trepanning is also making a hole, but for larger diameters of holes. Okay, right. The geometrical characteristics of laser drilled holes are described in terms of their aspect ratio, that is depth to diameter ratio at midspan of the hole. Okay, right. The aspect ratio depends on the optical characteristics of the beam and the optical and thermal properties of the material. Okay, so here the aspect ratio depends on the optical characteristics of the beam and the optical and thermal properties of the material. Okay, next one, deep hole drilling. In deep hole drilling of 0.25 to 1.0 mm in diameter, typical aspect ratios of more than 10:1 have been reported by Yu et al. So during 1994, Yu et al. Researched and reported that for deep hole drilling of 0.25 to 1.0 mm in diameter, the aspect ratio of more than 10:1. Okay, and an aspect ratio of 50:1 and drilling tolerance of plus or minus 5 to 20% of diameter has been reported in the machining data handbook. Okay, that is in 1997. So these are about the aspect ratios and tolerances of drilling a hole. Right. Next, taper and barreling. The degree of taper that ranges from 5 to 20% of the hole diameter decreases with an increase the hole depth. Okay. So what is happening here? The hole diameter decreases with the increase in the hole depth. Okay. Next, the taper depends on the pulse duration and energy, number of pulses, and the design of the optical system. Okay, so based on this, the taper depends. In general, the shorter the pulse duration, the greater will be the taper. Okay, so here if we reduce the pulse duration, the taperness will be increased. Okay, next, according to Aeronautical, during 1994, barreling formed by the ejection of material from the local sites of the cavity can be reduced by decreasing the pressure of the assist gas. Okay, next, selecting a low power density that effectively expels molten and vaporized material from the machining zone can reduce the precast layer. Using a short pulse duration and a low repetition rate to minimize heating in the surrounding material can reduce micro cracking. So here two important things are there. One is recast layer, the other one is micro cracking. So these two influence majorly for the quality of the hole. Okay. So generally the smaller depth of the altered layer associated with high cutting rates is an advantage of laser beam machining. Okay, right. Regarding entrance angle, the laser beam is capable of drilling holes with an entrance angle that varies from 10 degrees up to normal incident at 90 degrees with acceptable hole characteristics. Right, as the entrance angle with respect to surface becomes smaller, the effective surface power density is reduced. Under such circumstances, it is necessary to increase the power of the laser or improve the quality of the beam. So here majorly the entrance angle varies from 10 degrees up to normal incidence at 90 degrees. Right. About drilling time. Deep hole drilling up to 17 mm can be accomplished by operating the laser beam in the rapid pulse mode so that the total time is proportional to the amount of energy delivered per pulse. Okay, so these are the references associated to this topic, and let us wind up, and thank you very much.
Like, share, and subscribe. Hit the bell icon for more updates.